SpaceX Starship, the next frontier in space travel. SpaceX Starship represents a transformative leap in space travel that is poised to redefine the boundaries of exploration and revolutionize the economics of spaceflight. This ambitious vehicle, designed and developed by SpaceX, embodies an unparalleled level of innovation, combining cutting-edge propulsion technology, revolutionary materials, and an entirely reimagined approach to reusability. Its design is centered on achieving cost-effective, rapid, and reliable access to space, with a long-term vision of enabling human settlement on the Moon, Mars, and beyond. At its core, Starship is conceived as a fully reusable spacecraft that integrates two main stages: the Super Heavy booster and the Starship spacecraft. This configuration is a radical departure from traditional expendable launch vehicles that have dominated the space industry for decades. The Super Heavy booster, which provides the necessary thrust to escape Earth's gravity, is powered by a cluster of Raptor engines. These engines, fueled by liquid methane and liquid oxygen, are a critical element of the design because they offer high performance and efficiency while being built for durability and rapid reuse. The upper stage, known simply as Starship, is designed not only to transport cargo and crew into Earth orbit but also to serve as an interplanetary spacecraft capable of deep space missions. Together, they form a seamless, integrated system that minimizes turnaround time and dramatically lowers the cost per launch. The engineering accomplishments embedded in Starship are truly groundbreaking. SpaceX has pioneered the use of advanced stainless steel alloys for the vehicle's structure. This choice of material is significant not only because of its strength and robustness under extreme conditions, but also due to its durability and ability to reflect heat. The stainless steel exterior allows Starship to withstand the high temperatures encountered during atmospheric re-entry, while contributing to an overall reduction in maintenance costs. Coupled with an innovative heat shield system designed to protect sensitive components during the harsh phase of re-entry, the vehicle's structural integrity is maintained throughout every phase of flight, from liftoff to landing. A fundamental aspect that distinguishes Starship from previous vessels is its commitment to true reusability. Traditional systems, such as expendable rockets or partially reusable spacecraft, have long suffered from high operational costs and significant material waste. Starship aims to flip that paradigm by returning both the Super Heavy booster and the Starship itself for rapid refurbishment and relaunch. This design philosophy is integral to SpaceX's broader mission, which is to facilitate the routine and affordable movement of large payloads into orbit. With a projected payload capacity of over 100 metric tons to low Earth orbit, Starship is set to open new avenues for deploying satellites, space stations, and other infrastructure that would benefit from increased reliability and reduced costs. The vehicle's performance capabilities highlight the potential for drastically shorter turnaround times between missions. By eliminating the need to build new rockets for every mission, SpaceX envisions a scenario where the same vehicle could be launched, recovered, and refitted within weeks rather than months or years. This rapid cycle not only has the potential to accelerate scientific research but also to enable commercial endeavors such as space tourism and even intercontinental point-to-point travel on Earth. Imagine a future in which one could travel from one side of the globe to the other in under an hour, with Starship bridging the gaps between distant cities through suborbital or orbital trajectories. Starship's design is also aligned with humanity's long-term aspirations for space colonization. The vision of establishing a self-sustaining human presence on Mars and beyond has driven SpaceX to develop a spacecraft that is flexible in its mission profile. In addition to transporting cargo and crew to low Earth orbit, Starship is intended to serve as the primary vessel for missions to the Moon and Mars. Its large volume, both in terms of payload and habitable space, supports configurations for crewed missions that can include life support systems, living quarters, laboratories, and even recreational facilities. This adaptability is critical, as extended missions beyond Earth require not only robust transportation but also infrastructure that can support human life for extended periods in hostile environments. The integration of advanced life support systems and in-situ resource utilization technologies further reinforces the potential for long-term habitation on other planetary bodies, turning a visionary idea into a feasible engineering challenge. The iterative approach that SpaceX has adopted in developing Starship has been marked by a series of experimental prototypes and test flights. Each test, whether celebrated for its successes or analyzed for its shortcomings, contributes to an evolving design that addresses the myriad challenges of spaceflight. Early high-altitude flight tests have provided valuable data on the vehicle's aerodynamic stability, control algorithms, and landing procedures. These tests have shown that with incremental improvements and data-driven refinements, Starship is steadily progressing toward its goal of safely reaching orbit and returning to Earth. The process of iterative testing not only validates engineering principles but also fosters an environment of rapid innovation where lessons learned are quickly integrated into subsequent designs, reinforcing the reliability and robustness of the overall system. The propulsion technology employed by Starship, particularly the Raptor engine, represents a monumental leap forward in rocket engine design. Raptor engines are designed to operate with high efficiency over a range of conditions and are capable of deep throttling, which allows for precise control during both ascent and descent. Their performance characteristics enable the booster stage to deliver sufficient thrust while maintaining fuel efficiency, a balance that is pivotal for missions with heavy payload requirements. Additionally, the modular design of these engines means that any improvements in performance, material science, or thermal management can be rapidly incorporated into future iterations, ensuring that Starship remains at the cutting edge of propulsion technology as it advances toward manned missions and deep space exploration. The operational challenges that accompany the development of such a multifaceted spacecraft are numerous and complex. From managing the extreme thermal environments during re-entry to ensuring safe and controlled landings in varied geographic conditions, every flight test offers new insights into the delicate balance of forces that act on a vehicle traveling at hypersonic speeds. The development team must contend with aerodynamic stresses, thermal loads, and the unpredictable nature of weather and atmospheric conditions that can all influence the flight's success. Yet, the progress made thus far underscores the potential of an iterative design strategy that learns from each test to incrementally overcome these hurdles. The success of these efforts will determine not only the feasibility of Starship as a reliable transport vehicle, but also its long-term viability as the workhorse of SpaceX's ambitious plans for space exploration. Economic factors also play a pivotal role in defining the future of Starship. Reducing the cost of access to space has long been a critical challenge for space exploration, and Starship's design is firmly aimed at addressing this challenge. By reusing hardware, streamlining production through advanced manufacturing techniques, and leveraging economies of scale, SpaceX anticipates that Starship will make it economically viable to conduct frequent, large-scale launches. This reduction in launch costs is expected to democratize space, making orbital missions accessible to a broader array of customers, from governments and research institutions to private enterprises and even emerging startups in the space industry. Such a paradigm shift could stimulate a new wave of innovation across multiple sectors, driving technological advancements that further reduce costs while expanding the scope of what is possible in space exploration. The implications of Starship extend well beyond the realm of technical performance and economics. The spacecraft represents a cultural and aspirational milestone for humanity, symbolizing the quest to explore the unknown and to expand the frontiers of human experience. It challenges long-held assumptions about the limitations of space travel and ignites the collective imagination with the possibility of multiplanetary civilization. The bold and ambitious features of Starship serve as a rallying point for scientists, engineers, policymakers, and dreamers alike, instilling a sense of shared purpose as humanity embarks on its next great adventure. This vision of reaching out into the cosmos, of transcending the confines of our terrestrial home, underscores the fundamental drive of our species to explore, innovate, and evolve. In pushing the envelope of what is technically feasible, SpaceX and its Starship vehicle are redefining the route to space travel. The combination of fully reusable launch capabilities, advanced materials and propulsion systems, and a robust vision for interplanetary travel has the potential to not only lower the barriers to space but also to redefine the scale and scope of future missions. Whether the objective is to facilitate routine satellite deployments, pioneer deep space scientific exploration, or ultimately establish a human presence on Mars, the capabilities embedded within Starship are setting the stage for a new era in space travel. The innovations developed along the way are likely to cascade across the aerospace industry, influencing designs, methodologies, and operational strategies for decades to come. Starship is not merely an engineering marvel, it is a symbol of the relentless pursuit of progress in the face of seemingly insurmountable challenges. It embodies the collaborative spirit of innovation, drawing together expertise from multiple disciplines to confront and solve the myriad difficulties of space travel. As SpaceX continues to refine its designs, conduct more extensive testing, and integrate lessons learned, the journey toward a fully operational Starship becomes ever more tangible. Ultimately, the success of Starship could herald a transformative shift in human capabilities, enabling more ambitious space exploration missions, fostering global cooperation on interplanetary projects, and potentially opening a pathway toward the long-envisioned dream of settling other worlds. In this context, Starship stands as a testament to human ingenuity, ambition, and the unyielding desire to chart new horizons in space.